right, this is the fourth block of topic 19. In this block, we're going to continue to explore and apply some relationships among inscribed angles and arcs. So the first figure that is drawn on your notes is a triangle BAD, that is inscribed inside a circle. So it's called inscribed because all three of its vertices are on the circle. So in order for a polygon to be inscribed in a circle, it has to have all of its vertices on the circle. We are going to learn, what do we notice to be true about this triangle as a result of it being inscribed? So what I want you to do is to go ahead and pause the video and try to answer questions 1 through 4 in your notes. You have 5 answer choices here, and so you can pause and look at the answer choices, and you'll have one obviously that you're not going to use since there's only 4 questions and there's 5 answer choices. So pause the video and then you can check and see how you did. Okay, on the first one, I hope you recognized that angle BAD has its vertex on the circle. So remember, that's called an inscribed angle, and an inscribed angle is half of its intercepted arc. Since BD is a diameter, the arc that angle BAD intercepts is arc BED, which is a semicircle. And we know semicircles are 180 degrees. So we know this angle BAD is half of that 180 degrees, which is 90 degrees. So you can complete the statement. An inscribed angle is a right angle if and only if it is inscribed in a semicircle. Okay? So it would have to be half of 180 for it to be a 90-degree angle. And a 180-degree arc is a semicircle. So that's what you should have gotten on the first one. Yay, we got it right. All right, let's look at the second one. So see if you can solve this one. 2 lines intersecting a circle are parallel if and only if what? Okay, so we're looking at these 2 lines, AB and DE, and we're trying to know how we know they are parallel. Well, parallel lines, remember, never intersect, and so the distance between them has to remain the same. And so if the distance between these 2 lines is the same, then this arc AD would have to be congruent to this arc BE. So 2 lines intersecting a circle are parallel if and only if the lines intercept congruent arcs. That is the only way those lines can be parallel. They have to be the same distance apart. Let's look at the third one. It says, if inscribed angles on a circle intercept the same arc, then what has to be true? So let's see what they're talking about here. If you look at angle DAC, its vertex is on the circle right here at A. Or I guess they're really wanting us to look at this one. Let's look at this angle instead. I'm sorry, I'm looking at the colors now and realize which one they're wanting us to look at. If we look at angle ADB, the vertex of that angle is vertex D, point D, and it's on the circle. So we know that's an inscribed angle, so it is half of its arc. What arc is it intercepting? We'll follow the sides of the angle to point A and point B. So it's intercepting arc AB. So angle ADB would be half of arc AB. Now let's look at this angle, angle ACB. Again, its vertex is on the circle, so it is an inscribed angle, so it is half of its intercepted arc. What arc does it intercept? We'll follow its sides. You follow its sides to point A and side B and point B. So again, it also intercepts arc AB. So this angle is also half of arc AB. So if both of these angles are half of the same arc, what relationship do they have to each other? They would have to be congruent. If they're half of the same number, then they have to be congruent to each other. All right, let's look at the last one. It's a quadrilateral that is inscribed in a circle. I know it's inscribed because all 4 of its vertices are on the circle. It says, if a quadrilateral is inscribed in a circle, then what do we know to be true? This one's a little bit tricky, so let's talk about this for just a moment. So let's look at angle Q. Angle Q is an inscribed inscribed angle, so it is half of its intercepted arc. If you follow its sides, you would go to U and D. So it would be half of arc UD. Let's look at the angle opposite angle Q, which is angle A. It's also inscribed because its vertex is on the circle. So it would be half of its arc. If you follow its sides, you would also go to U and D, but we're not talking about the minor arc UD that Q was half of. We're talking about the major one, UQD. So angle A is half of UQD, and angle Q is half of UD, right? Well, together, UD and UQD make up the whole circle. And so together, A and Q would have to be half of the whole circle. And what is half of a whole circle? Well, a whole circle is 360 degrees, so half of that would be 180. So that tells me angles Q and A, which are opposite angles, have to be supplementary. They have to add to be 180 degrees. So if a quadrilateral is inscribed in a circle, the opposite angles have to be supplementary. So let's look and see what that means to us. If you are given expressions for these two angles, if you're given this one is 2x and this one is 3x minus 10, you're going to use the fact that they're supplementary to set up your equation. You would solve 2x plus 3x minus 10 equals 180. The opposite angles of an inscribed quadrilateral have to be supplementary. So if you're given this one to be 80 degrees, you would know this one has to be 100 degrees because they have to be supplementary. All right, so it says, how could you inscribe a rectangle in a circle? If you'll remember from topic 17, we learned some properties of rectangles that would help us here. One of those is the fact that the diagonals of a rectangle have to be congruent. Well, if you inscribe a rectangle inside of a circle, I'll attempt to draw one here. If we had an inscribed rectangle, remember all four of its vertices would be on the circle, its diagonals would be what part of the circle? Well, they could be diameters. So if you just create two diameters intersecting that are obviously going to be congruent because the diameters of a circle would be, then if you connect where they hit your circle, the points that are on the circle, you would create a rectangle because you just use the fact that the diagonals are congruent, and so it'd have to be a rectangle. Now, it might be a square, right? You could be creating a square, but a square is a rectangle. So that is one way to inscribe a rectangle in a circle. All right, good luck on your homework.